for you. Number 2, let's find our equivalent capacitor for this diagram. Oh yeah, look at this now. How do we resolve this question? This, and this are in what? In series, Abi? Is it not? Which one is 200? Is that 200? The up one is 200, sorry. Microfarad, Abi? Is it not? These 3 are in what? In series. I can resolve this in series, Abi. What do you have? 50. Is it not? When you resolve the 50 with this, what do you have? Let's check. Let's call here what? C1, Abi. Here what? C2. Here C3. Here C4 and what? C5, right? C3, C5 and C4. C3, C4 and what? C5 are in what? And series, Abi. That means that we have what? What's the equivalent? That will be 6, 6, right? What's 6, 6 here? 1 over what? C3. Let me just add up. 1 over 200, plus 1 over what? 100 plus 1 over what? 100, right? Always power what? Minus 1, is it not? Is it not? We are adding this now in series. 1 over this plus 1 over this plus 1 over this. Always per minus 1, is it not? So 6, 6 becomes what? What's the LCM here? 200, right? What do we have here? 1 plus what? 2 plus what? 2, Abi? And that will give us what? That will give us what? 166. 5 over what? 200 always per what? Minus 1, Abi? That means our 66 becomes what? 200 over 5, which is equal to what? 40 what? Microfarad. Is it not? Is it not? Okay. 40 microfarad. Now we have been able to resolve this as 40. Can I hear? I hope you are learning. Listen. Our C6 is this, Abi. Can we restructure this now? This becomes what? Let's watch. What do you have here? 30, Abi. Okay, 300 microfarad, right? Here we have what? Are you following? So the whole of this is now what? In parallel with this, right? Okay, it's now in parallel with this. Okay. So we call this what? Our 60s, right? And that was our 60s. 40 microfarad, right? What is here? This is our C2, which is what? 60 microfarad. This is what? C1, is it not? Now what do you notice? C2 and C6 are in what? In parallel. C2 and C6 are in parallel. So what do you think will be the equivalent? 6, 7, right? And what 6, 7? C2 plus what? C6, Abi, which is 60 plus what? Plus 40. And that will give us what? 100 microfarad. So that means that whatever you have here is now in series with what? With C1, Abi? Is not? Is it not? This is still what? Our C1. This becomes what? Our 6, 7. What's the C1? 300. What do you have here? 100. So in series becomes what? C what now? 8. Abi? What's the C8? 1 over 300 plus 1 over what? 100. Always power what? Minus 1. These two are in series. Is it not so? Right? And what's the answer? C8 becomes what? What's the LCM here? 300 into 300 is what? So we have 1 plus what? 3, right? Always power what? Minus 1. So yes, C8 then becomes what? 4 over what? 300. Always per minus 1. What's our C8? 300 over what? 4. What's the answer here? 75 microwatt farad. Is it not? So that means that we have our cell connected to what? A single what? Capacitor. We have our cell connected to a single capacitor, which is what? 75 watts microfarad, right? What is cell? 400 voltage, right? Number 3 says that two capacitors, 12 microfarad and 6 what? Microfarad, are connected in series and then connected to an external source of 1000 volts. Find number 1, the total capacitance, Abi. Number 2, the charge on each capacitor. Number 3, the potential drop across each capacitor, which is your voltage. Look at it here. We are told that what? Two capacitors, and what is it? Our C1 is what? 12 Abi, microfarad. What's that C2? 6 microwatt farad. They are in what? In series. So we have this connected to this in series, right? Is it not? So what is it? Here we have 12 microfarad. Here is what? 6 what? Microfarad. Connected to an external what? Battery, Abi. Are you following? Of what? 1000 watt volts. Are you following? Since they are in series, that means the charge on this is the same charge on this. But let's resolve this first in what? In series. So we have C1, here's what? C2. So what do we find? Let's find C3 or C equivalent, right? That will give us 1 over what? C1 plus 1 over what? C2. Always for what? Minus 1. This is your past question I'm solving. Please pay attention. This is your past question. Everything here is your past question. So let's go. What's that C equivalent? 1 over what? 12 plus what? 1 over what? 6. Always for what? Minus 1. So our C equivalent then becomes what? What's the SM here? 12. 12 into 12 is what? 1. 1. 12 into 6. So we have 1 plus 2. Always power what? Minus 1. Our C equivalent becomes what? 3 over 12, which is same as 12 over what? 3 equals to 4 microfarad. This is our C equivalent. Now the next is to find what? The charge. Abi? The charge. Okay. The next is to find the total charge. The total charge, our charge total is equal to what? C equivalent, right? Times what? V total, is it not? So our Q becomes what? What's that C equivalent? 4 times 10 raised power what? Minus 6. 4 microfarad. Multiplied by what? What's that V total? 1000. So what do we have here? Here becomes 4000 times 10 raised power what? Minus 6 column. In standard form, what do we have in standard form? 1, 2, 3, right? Is it not? Here should be about 0.004 coulomb, is it not? This is our total charge. Then, because since C1 and C2 are in series, that means the charge on C1 is the same charge on C2, is the same total what? Charge. Are you following? Since C1 and C2 are in series, therefore, our charge total equals to what? Q1 equals to what? Q2 equals to what? 0.004 coulomb. That implies that our Q1 is 0.004 coulomb. What's our Q2? 0.004 coulomb. Are you following? Okay. Now, if we can get this, then we can now find the potential drop across each what? Capacitor. Because they are in series, that means they will have different what? Different potential what? Drop, right? Okay. So how do you find the potential drop? PD across C1 is V1, right? Which is equal to what? Q1 over what? C1. What's that Q1? 0.004. Divided by what? What's that C1? 12, right? 12 times 10 raised power what? Minus 6. Please divide this. What do you have? 3 volts. Huh? Are you sure of this value? Okay. Alright, so the next one is that our V2 is what? Q2 over what? C2, right? And that will give us what? That will give us what? What's that Q2? 0.004 divided by what's that C2? 6 times what? 10 raised power minus 6. What's that V2? What's that V2? 666.67 volts. Are you following? Now let's check if our answer is correct. The total voltage here is what? 1000. By the time you add the voltage in C1 and that of C2, you must have 1000. Is it true? Let's add up. This plus this should be equal to 1000. Right? 1000. Okay. Please write. We are number 4. Okay, the next question. Please, let's pay attention. Say that prove that the electrical potential energy stored in the plate of a capacitor is U equals what? Half QV or what? Half Q square over what? Over C, right? We want to prove that this is equals to what? Potential energy. Are you there? You know, we talked about if we have a capacitor, a parallel plate what? Capacitor, right? A parallel plate capacitor connected to an external source. Are you following? Okay. This battery supplies what? Energy, right? Are you there? The energy supplied to the movement of the charge is equal to the potential energy or work done by that charge. The energy supplied equals to the work done. It's like saying, for example, now, if I'm to move from here to what? To that point. Are you there? The work done by me moving equal to the energy. What's the energy? The kinetic what? Energy. But here we are talking about potential what? Energy. So the energy supply, okay, is equal to the work done on the capacitor by those charge. And recall that we say that work done is equal to work done is equal to what? VQ, Abi? Are you aware? VQ. Potential drop is equal to work done over what? Charge. But a little change in work is done by what? V times what? A little change in what? In the charge. A little change in work is done by what? A little change in what? In charge. Now recall that charge is equal to what? CV, right? Are you aware of this? Let's call this equation 1, this equation 2, this equation what? 3. I will make my V as what here? On the formula. To stand alone. So V becomes Q over what? Over C. So when V becomes the subject, we have this, right? And that will give us what? Equation what? 4. Are you following? Now, I'm going to put equation 4 into what? Equation what? 2. You know we got this from this. V equals to this from this. So let's put our V as Q over C into equation 2, which is our change in work done, right? Equals to what? V dot what? The Q, Abi. So we are changing work done equals what's at V now? Q over what? C dot what? A change in what? In charge. Are you there? Now, whenever you see a system like this, it simply means I have to integrate. I have to what? Integrate. In mathematics, if I have this, let's say integral of x raised to power n or in the x, I'm to integrate. The rule says what? Integral of what? Sn equals to what? S raised to power n plus 1 over what? N plus 1 plus c. To integrate means I'll be adding 1 to the resulting power. Then divide by what? By the resulting power. If I have here to be s squared, what will it be? 2 plus 1 over what? 2 plus 1. Do you get it? But you have to add what to it plus c. Now we say integrate both sides because I have a change in work. The only thing we have to do here is to what? Integrate. This is equation, what is this? Equation 5, Abi. Then we say integrate both sides. Integrate both what? Sides. So we have integral of change in work equals integral of what? Charge over C dot what? dq. The right to integrate charge is what? dq. Are you there? I will now integrate. Don't forget that when you integrate the x, your answer is x. Integrate the u, the answer is what? U. Integrate the w, what's the answer? W. So if I'm to integrate this, what do you have? W. W equals, then for this, if I'm to integrate this, this is same as 1 over c. Integral, let me bring out this again. Q the what? The Q over what? Okay? I just brought out 1 over CRB, which is same as this. Now, for me to integrate this, it means our work done becomes what? 1 over C times, what the power of Q here is 1. The rule says what? We add 1 to the power, which is what? Q1 plus 1 over what? 1 plus 1 plus what? C. So work done becomes what? 1 over C times what? Q square over what? Over 2. And what do you think is the work done now? Is half Q square over what? C. This is the first one, right? I think the second one, which is this, is it not? Is it not? But because we say that the potential energy possessed, okay, is equal to what? The work done, is it not? That means that our energy U is equal to what? Half what? Half what? Q square over what? Over C. But let's see how we can derive this now. I can express this. Recall that this can be expressed as what? Half times Q over C times Q. Do you agree with me? Because Q times Q is what? Is Q square, right? So Q over C, what we define as? V. Do you get the gist? So if V equals to Q over C, so we say, since V equals what? Q over C, that means our energy then becomes what? Half what? V times what? Q. And that will be what? U equals what? Half QV. Right? Is that? Yes. Number 5. The next question, number 5 says, with diagram, explain what happened when, number 1, 2 what? 2 positive what? Charges are brought close to what? Close to each other. Okay? And separated by what? Distance R, right? Okay. And separated by distance R. Now, if you look at this now, you'll be a kind of confused. Although there are 2 ways we can represent this. But for IMSU past question, IMSU, what they're expecting from you is that 2 positive charge, when they are together, what happens? They will repair. Abi? This is what you are going to do for them here. We're going to bring out this here, then bring out this here. Then here we have what? Positive. Here's what? Positive. The distance of separation is what? Is R. Are you there? This is what you are expected to what? To draw. Alright? Number 2 is what? 2 unlike what? Charges. Number 2 is 2 unlike what? Charges. Okay? For 2 unlike charges, what do you notice will happen? They will attract, are they? So it will be in this form. In this form. Here we have what here? Positive and what? And negative. Are you following? To be in this form. What again? The third one is what? 2 negative what? Charges. The same thing we obtain here. To just be this. 2 negative charges. That will give us the same diagram here. We're going to have negative and what? Negative. Distance is what? R, Abi? Distance R. Here we have our distance R. Our distance R. Or in between here, right? Our distance R. Are you there? This is out your textbook. This is for unlike. That means they are attracting. Attracted. This is what 2 like. They are repairing. This for 2 negative charge, repairing. Even if I have plus, they will also repair. But if they are of different sign, they will attract. So we have to state the importance of force. Dielectric, Abi. Number 1 importance. Listen. That electric increases. If you remember very well, I said it decreases what? The capacitance, Abi. Capacitance of what? The capacitor. Is it not? From this relationship I gave, we C equals to what? K. K what? C, no, Ka, permittivity of free space divided by what? D. Remember that? Eh? Remember, right? So if I'm to introduce a material, it will increase what? The capacitance. Number 2 is that it increases the amount of charges. Amount of what? Charges. In a what? Capacitor. It helps to increase the amount of charges in the capacitor. It helps to increase what? The amount of what? Charges, Abi? In a what? In a capacitor. Is it not? By Q equals to what? KQ what? Q naught. By Q equals KQ naught. Let me explain this. This is what? The charge, Abi? When there's a what? When there's a what? Dielectric material. If I'm to introduce a material to a capacitor that has a charge, that has what? A charge, Abi? When air is the what? The material. You know, I told you guys that if I have air here, what's that Q here? Q naught, Abi? From our derivation. Isn't that so? So for me to generate a normal charge, it simply means what? I have to introduce what to it? Huh? A dielectric material now. That will not give us what? The charge acquired by what? The capacitor. So that means that if I'm to introduce this, it will increase this. Because these two, they are what? Directly what? Proportional. So addition of what? Of K, we increase what? The charge. Are you following? I think this also has a derivation, isn't it? Go back to my YouTube video, you see that I derive it, something like this. Yeah? K equals to what? KQ naught. Are you aware? Huh? Which one? This one? Ka permittivity of space divided by D, yes. This is called capacitance of what? Of parallel plate what? Capacitor. You saw what happened this morning. Now, when we derived this formula, we found out that if we are to increase the capacitance, we have to introduce what? A dielectric what? Material. But if I have air, what's capacitance? C naught equals to what? K, sorry, A what? Permittivity of free space divided by what? D. I can still use it, but your K is equal to 1 for air, Abi? But the gist here is that by the time we introduce this, let's say for example now, if I have just 1 here, and let's say I have C equals to 4 A naught over what? Over D. What do you notice here? What's our K here? What's our K here? 4. What's our K here? 1. Which one will have more capacitance? Is this. Because 4 times this will increase the value of what? Capacitance. Do you get it? The gist now? Okay, so what else again? Number 3 is that we are looking at for the function of the importance, Abi. Number 3 is that dielectrics lowers the electric what? Field. It lowers the what? Electric field. It lowers the electric field by a factor of K. By a factor of what? K. By a factor of K. Meaning that our electric field is equal to what? Our E naught over what? Over K. Meaning, if you look at this relationship, look at this. All of these have derivation, but I won't go into it now. If I'm to, between this and this, they have a negative relationship, right? Meaning that if I'm to increase this, it will what? Reduce this. So addition of this will actually what? Reduce what? The intensity. Isn't it so? Are you following now? So what happens here is that it lowers what? Electric what? Field. Number what now? Number 4, it also lowers the potential what? Difference. Do you know why? Recall that V is equal to what? ED, Abi? E and V, they have a direct what? Relationship. Whatsoever that happens to what? Your E also happens to what? Your V. Are you following? So if dielectrics lowers what? Your E, that means it must also lowers what? V. Did you get the concept here? But the actual relationship is what? Is V equals to what? V naught over what? Over K. This is the relationship here. I would have loved to show us the derivation, but let's just take it that way. So for the first one, our C is what? A permittivity of free space divided by what? D. Second is what? Q equals what? K, Q naught. What's the third? E equals what? E naught over K. What's the fourth one? V equals what? V naught over what? K. Huh? For those that missed today's class, please make sure you take notes. Take note of this. We derived this morning. Listen, please. Another way they can ask this question is that what are the effects? Hello? What are the what? The effect of what? Effect of what? Dielectrics. Don't forget. It's the same as the importance of what? Dielectrics. They might say, what are the effects or the importance? Are you there? It's the same thing. The first is that it increases the capacitance of a capacitor. Number two, it increases the amount of charges in a capacitor. Number three, it lowers what? Electric field. Number four is that it also lowers the potential difference. The next question says that, very simple. Define capacitance. Number 7, define capacitance and give the expression. Okay, and obtain, not give. And obtain the expression. Yeah, it's the same thing. Expression for the capacitance of a parallel plate conductor. Concept what? Define what? Capacitance and obtain the expression for the capacitance of a parallel plate capacitor. Parallel plate what? Capacitor. Parallel plate capacitor. Who can define for me what is capacitance? The ability of what? Is the ability of what? The capacitor to store electrical what? Charges, Abi? Right, please. Capacitance is defined as the ability of a capacitor to store electrical charges. And they say, obtain the expression for the capacitance of a parallel plate capacitor. Obtain the expression. Are you following? Who can solve this for us? Who can obtain the expression? You have forgotten what we did this morning. If I have a parallel plate capacitor, you have forgotten, connected to an external what? Source, right? Are you following? The first is to assume that air, right? Is it not? When this is being charged, what is charged here? C naught V naught, Abi? Is it not? The charge on this capacitor, when air is the material between the two parallel plates, is given as what? Q naught equals to what? C naught what? V naught. Is it not? Equation what? 1. Are you aware? This charge here will generate what? Electrical what? Flux, Abi? And according to Gauss law, we say that the flux generated is equal to the charge over what? Permittivity of what? Free space. Is it not so? Are you aware? This equation what? 2. Sorry, this same flux is equal to what? EA. But our E is what? E naught times what? Times A, right? Where A represents what? The area of the what? Of the plate, right? Alright, so from here, our charge. The charge on the capacitor is what? Q naught over what? E naught, Abi? Equals to E naught times A, right? When air is the what? Dielectric material. We did it this morning now, is it not so? Then here we now multiply, is it not? So we have our charge, Q naught becomes what? E naught times what? A, right? Is it not? This is equation what? 2, right? Or we can say this is same as E naught A, permittivity of free space, Abi? Equation 2. So we're going to equate this and this together because they have the same charge. So we equate equation 1 and 2. That means our C naught V naught equals to what? E naught A, permittivity of what? Free space. Right? So how do we find our C naught? We divide both sides by what? By V naught. So C naught becomes E naught A, permittivity of free space, divided by what? By what? V naught, right? So this will give us then we say recall that what? V equals to what? ED, right? Are you aware that V equals to ED? But in this case, what's that V here? V naught equals to what? E naught D, right? Are you aware? Because we are dealing with air. So that means that by the time we put this, let's call this equation what? 3. We put this into equation 3. That will give us our C naught equals to what? E naught A, permittivity of free space divided by what? E naught D, right? Can this go with this? So our C naught becomes what? A E naught over what? D. Then recall that we say our C is equal to what? K C naught, right? So this becomes what? C equals to what? Our K times, what's that C naught? A, permittivity of free space divided by what? D. This is the capacitance of a parallel plate what? Capacitor. Are you there? When air is not the dielectric what? Material. Are you getting it? Okay. Number 8. Question 8. Hello. The question says that a TV receiver, right, contain a capacity of what? 10 microfarad. So our C is giving us what? 10 microfarad. Are you there? Charged to a PD of 20 kilovolts. What's that PD? 20 kilovolts. Kilo means what? 1,000, right? Which is same as what? 20,000, right? Volt. Are you aware? Once again, calculate the charge and potential energy stored in the capacitor. We have to find what? The charge. This V can also be expressed as what? 2 times 10 per what? Let's check. 1, 2, 3, 4, right? This power 4 what? Volts. So the charge is equal to what? CV, right? So what's that charge here? What's that C? This is same as 10 times 10 per what? Minus 6 farad, is it not? So we have 10 times 10 by minus 6 multiplied by what? 2 times 10 per what? 4, right? So what's that charge now? What is 10 times 2? What's 10 times 2? 20. 10 times per what? Minus 6 plus 4 is what? Minus 2 what? Coulomb, right? So this is same as what? This is same as what? 0.2 what? Coulomb, right? Okay. The next one says, well, find the what? Find the what? The potential energy stored, Abi, in the capacitor. The potential energy, what's our formula again? CV square, right? Our energy is what? Half CV square. Are you following somebody? So that means our U becomes what? Half times, what is our C? Our C is what? 10 times 10 per what? Minus 6. What is that V? 2 times 10 per what? 4, right? All squared. Are you following? So U becomes what? Can this go with this? 5 times 10 per minus 6 times 2 squares what? 4 times 10 per what? 8, right? So 5 times 4 will give us what? 20 times 10 per what? Minus 6 times, minus 6 plus 8 is what? Will give us 2. So this will give us what? U equals 20 times what? 100, right? And that will give us what? 2,000 what? Joules. Are you following? This question says that, number 10, please, given a 7.4 picofarad L-field what? Capacitor. You are asked to convert it to a what? Capacitor that can store up to 7.4 microjoule, right? With a maximum of what? 652 voltage. What dielectric material, constant rather, should the material have that you install to achieve this what? Requirement? Do you get what I'm saying now? Like what we discussed before, that if we have air We are told that the material has what? 7.4 picofarad air-filled what? Capacitor. Do you get? We are given our C naught as what? 7.4 picowatt farad. For me to achieve a maximum capacitance, what do? We have to introduce what? A dielectric what? Material, right? That is not air, is it not so? Now, did I ask that what constant value will that material have to achieve what? This requirement? This is a very simple question. Look at it. Let's bring out what we have here. Given a 7.4 picofarad air field, that means our C naught is given a B, right? What's that C naught here? 7.4 picowatt farad, which is same as what? 7.4 times 10 per watt minus 12 watt farad, abi? Good. And we have to convert it to what? A capacitor that can store up to what? 7.4 microjoule. So the energy here is what? 7.4 what? Microwatt joule, right? Which is same as what? 7.4 times 10 per watt minus 6 joule, right? Okay. With a maximum voltage of what? What's our voltage? What's our voltage? 652 volts. Then they say, what dielectric what? Constant to the material have that you insert to achieve this requirement. This is a very simple case here. What's the energy we say? Energy is what? Energy is equal to what? Half what? CV, right? Can this go? Half CV square. Our energy, recall that energy equals to half CV square. But don't forget that, also recall that capacitance is equal to what? C what? K what? K what? CO. That means I can replace this with what now? With this, Abi. And that will give us what? Energy becomes what? Half what? Half KCO V square divided, half KCO V square. Do you get? This is when we have energy, right? Stored when the material is not what? Air. But since we are told that given a 7.4 picofarad air-filled what? Capacitor, and I have to introduce what? My CO to it. Knowing that this exists, and I gave us that your C equals what? KCO. Is it not so? Is that your notes? Good. Now we have to find what? The value of K, right? So from here we can say that I can actually cross multiply, right? This will give us what? 2U. This expression is also same as U equals what? KCO V square divided by what? 2, right? Over what? 1. Can we cross multiply? That means our 2U is equal to what? KCO V square. So how do we find our K? The K becomes what? 2U divided by what? CO V square. And that will give us what? 2 times, what's the energy here? What's the energy? 7.4 times 10 per what? Minus 6 divided by what? What's the CO? 7.4 times 10 per what? Minus what? Minus 12 times, what's that V? 652 all what? All squared. Let's multiply the numerator. What we have? Let me use this small space here to solve the remaining. But let me just continue with this. Our K becomes what here? 2 times 7.4 is what? 14.8 times 10 per what? Minus 6, right? Divided by what? Please evaluate this for me. 652 square. What do you have? Multiply by 7.4. 3145 769.6, right? Times 10 raised per what? Minus 12, right? Let's see what we can do here. Let's move our points backward a little. 1, 2, 3, 4, 5, 6, right? Is it not? Here will now become what? Minus 6. Hope you are aware. If I'm moving my point from the right towards the left, I'm adding now. So from here, when we move from here, 1, 2, 3, 4, 5, 6. Here becomes 3.14 times 3 per what? 6, minus 6. So that this can cancel this, right? So that means that our K should be equal to what? About 14.8 divided by what? Let me bring out this. Times 3 per what? Minus 6 divided by what? 3 point what? 14. Put your answer for me in 4 decimal place. 1458 abi 14548 times x per what? Minus 6. Can these two cancel out? So divide the value of k for me. What do you have? 14.8 divided by 3.1458 is what? 4 point what? 7. So the material must have what? A constant value of what? 4.7. The material, no units, no units. The material must have a dielectric constant, abi? Dielectric constant of what? 4.7. Do you understand the concept? Is it clear? Number 12 is very simple. Number 12 says that, listen, all of you, listen. To achieve a very large capacitance, what variable must be considered in designing a capacitor? It simply means factor that determine what? Capacitance of the capacitor, abi? One is what? Area of the plate. Two is what? Distance between the two plates, abi? Nature of the material, which is your what? Dielectric what? Material. What again? I mentioned all that ones, like 4 and 5. The amount of what? Charge, abi? What again? Intensity and what? Your voltage. But in the exam, just mention the first three, or the first three, which is your area, right? What again? The nature of the material and what? Distance separating the two plates. Some might even say the permittivity of the material. Are you aware? Because it's part of the formula, right? That says that C equals to what? Ka. Permittivity of it be divided by what? D. Is it not so? All of these things here determines the value of your C. Everything is just here. One is your distance, abi. Two is what? Area. Three is what? The material. Are you following? Therefore, can also be what? Permittivity of free space or of the material itself. Are you following? And I want you guys to take note that the permittivity of other material, please note this. If you can write. The permittivity of other material is equal to what? K what? Permittivity of free space. The permittivity of other material equals to permittivity of free space times K. That means that to determine the permittivity of other material, what we do is to add what? A dielectric material into what? Into a capacitor that has what? L what? Field. Do you get the concept now? It means I have to replace my air with a different what? Material to get the what? The permittivity of that material. Is it making sense? Just like this also. To get the capacitance of other material, I have to add what? A dielectric material to a what? A capacitor that has what? Air field. That will give us what? Capacitance of what? Of that material. Is it making sense now? Yes. Even that of charge, your Q equals to what? KQ naught. It simply means that one of the factors that affects capacitance, like we said, is what? So one of the effects of what? That material is that it increases what? The charge, abi? Is your note. I gave you four effects of what? Dielectric material. Is it also? One of them is that it increases the amount of charges. From here, by the time we add what? Your material to an L field or capacitor, that will give us to increase the amount of charge. Are you there? But once I have something like this, E equals to what? E naught over what? K. This becomes a negative relationship between your what? Dielectric material and what? And your field was strength, abi? Meaning that once you introduce any material, it will do what? It will reduce the what? The strength of the field. But they are what? Inversely proportional to each other. Do you get the concept here? Likewise, your voltage. What's your voltage? Equals to V naught over what? Over K. Because your V equals to what? ED. Like I said before, whatsoever happens to your voltage also happens to your E. If your value of K will affect V, it means it also affects what? E, because they are both what? Directly what? Proportional to each other. And if I don't want to go into derivations, there are many derivations I would like to show, but you don't need them. It's for those studying physics, yes. The last one, number 11, we have seen number 12 already, right? Number 12, we have seen the factors that must be considered to have large what? Capacitance. To have large capacitance, we have seen the factors. Number 11 says a parallel plate capacitor has plate Please take note of this question. If it's the only one you can get today, just get it. A parallel plate capacitor has plates of dimensions 2.0 cm by 3.0 cm, separated by 1.0 millimeter thickness of paper. Find its capacitance. Find what? Its capacitance. In brackets, K equals to what? 3.7. Please pay attention and listen. A parallel plate capacitor has plates of what? Dimension 2.0 cm by what? 3.0 cm. That means we can find the area of the parallel plate. Abi? An area is what? The length is breadth. Abi? Are you following? We have this. We are told that the height is what? 3. The length is what? 2. Isn't it? So let's find the area. The first is to find the area. What's our area there? 2.0 cm times what? 3.0 what? Cm. And that will give us what? 6 cm what? Square, right? Are you aware? So let's convert this 6 cm square to what? To meter square. That will give us what? 6 over what? Over what? Is it 100 or 1,000 or 10,000? Over 10,000 now. To convert cm to meter, divide by what? 100. To meter square. I'm converting cm square to meter square. That means I'll multiply 100 by what? 100. And that will give us what? 10 what? 10,000. Isn't it? So that means to convert 6 cm square to meter square, I will divide this 6 by what? By what? 10,000. And what do we have? Give me the value. 6 times 10 per what? Minus 4 what? Meter square. Thank you. What thing was given there? It said by a distance separated by what? 1.0 millimeter, right? Thickness of paper. That means our distance there is what? 1.0. Is that 1.0 millimeter? Which is same as what? 1 times 10 per what? Minus 3 meter, right? Okay. Now we are now to find its capacitance when K is equal to what? 3.7. Now they gave you K. That means a material is now introduced into what? The capacitor. Isn't it so? This is not L-filled what? Capacitor. If K is not given, that means it's L-filled capacitor. Are you following? Then tell them that recall that capacitance is equal to what? K what? A, permittivity of free space divided by what? D. So C becomes what? What's that area? Let's go. 3.7 times, what's that area? 6 times 10 per what? Minus 4 multiplied by permittivity of free space has a constant value, right? Of what? 8.85 times 10 per what? Minus 12. So we have 8.85 times 10 power minus 12. Are you following? Divided by our distance of separation is what? 1 times 10 per what? Minus 3. So our C then becomes what? What's our C? Please also multiply from the numerator. 3.7 times 6 times 8.85 is what? 196.47 times 10 per what? Minus 4 minus 12 is what? Minus 16. Divided by what? 1 times 10 per what? Minus 3. When you divide all of this by 1, we still have this, Abi. So that means we're going to add what? The power. When you bring minus 3 upward becomes what? Plus what? Plus 3, Abi. So what do you think will be the final answer now? Our answer becomes what? For C becomes, let's go, 196, right? Point what? 47 times 10 per what? Minus 16 plus what? Plus 3, right? So that will give us our C becomes 196.47 times 10 per what? Minus 13. So let's put this in the normal proper standard form. What we have? This becomes what? C equals to what? 1.96 times 10 per what? Minus 11. Okay? Minus 11 what? Farad, right? Okay, do you know that I can swear this can also be 19.6 picowatts farad. Are you aware? Because when you move your point, say your point is here, what will be the power here? Minus 12. And minus 12 represents what? Pico. So here becomes 19.6 pico farad. Is it clear? Are you sure? I believe you can solve the last one, right? Number 13. You can, Abi. But let me see some for the sake of my viewers. Okay? Hello, viewers. Hope you are enjoying the class. All right, let's continue. All right. Now, we are given this to find the word equivalent word capacitance, right? Are you there, somebody? So what are we going to do here is that C4 and C5 are in what? In series, right? Let's resolve these two as a single what? Capacitor. So we say C4 and C5 are in series. Therefore, right? Therefore, what will be the next capacitance? 6, 7, right? Is it not? 6, 7 becomes what? So I will resolve these two to form what? 6, 7. And that will give us what? 1 over what? C4 plus 1 over C5. All is power what? Minus 1. So C7 becomes 1 over what? 1 C4. 1 C4, 2 plus 1 C5, 1 over 6. All is power what? Minus 1. So C7 becomes what? What's that C7 now? SCM between these two is what? Is 6. 6 into 2 is what? 3. Times 1, 3 plus 6 into 6 is what? Times 1, 1, right? All is power what? Minus 1. So 6, 7 then becomes what? 4 over 6. All is power what? Minus 1, right? So what's that 6, 7? 6 over 4. Always, sorry, 6 over 4 rather. Sorry. And that will give us what? In decimal, what do you have? That will give us 1.5 microwatts farad, right? Okay. Now, then the new diagram becomes what? Becomes this, right? It simply means that all I have here to be our C1, followed by what here? Followed by this, right? Here becomes this, right? Okay, here is what? C3. Here we still have our what here? This is our C2, right? Okay, are you there? So this is now what? In parallel with what? With this, right? The one of this represents what? C7. And that's 1.5 microfarad, right? Yeah, what do you have here? 3 microwatt farad. What do you call here? C6. What do you have here? 45 microfarad. What do you call here? And here's what? C1, which is what? 5 microfarad. And here's what? 2 microfarad. Now what do you notice? 6, 7 and 6, 6 are in what? Parallel. So we resolve them. 6, 7 and 6, 6 are in what? Parallel. You said? No, it's not among. We still have this here. I can't resolve this way. So I have to just resolve this first in parallel. Are you there? So let's watch. And that means that in parallel means what? C what? C8, Abby. So C8 becomes what? C7 plus 6, 6. What's that C8? What's C7? 1.5 plus what? 3. And that will give us what? What's that 6, 6? It's 3, yeah. When you add up, what do you have? 4.5 microwatt farad, right? Okay. So our new diagram becomes what? Becomes what? This, Abby. Let's see our new diagram now. Okay. Here we have what here? C1. Here becomes what? C8, Abby. Here becomes C3. Are you seeing it? So here we have here to be our C1. Our C1. Here we have C2. Here we have C3. Here we have C8, right? Right? What's that C2? 2 microfarad. What's that C1? 5 microfarad. What's that C8? 4 point what? 5 microfarad. What's that C3? 45 microfarad. Now, these three are in what? In series, Abby. Now, since they are in series, here becomes what? We have C1, C8, and what? C3 in what? In series. That means our C now becomes what? 1 over what? C1 plus 1 over what? C3, C8 plus 1 over what? C3. All raised power what? Minus 1, right? So C now becomes what? 1 over what? That's C1? 5 plus 1 over what? What is C8? 4 what? 4.5 plus 1 over C3 is what? 45. Always for what? Minus 1. What's the LCM between these three? What's the LCM? 45. Okay. So C9, eh? So C9 becomes what? 45, right? Into this is what? 9. What about this? 10, Abi? What about this? 1. Raised by what? Minus 1. So C9 becomes what? 20 over what? 45. Always power minus 1. What does C9 now? 45 over what? 20. And what do you have here? 2 point what? Micro what? Farad. But are we done? No. We have only resolved this, Abi. Where is it? We have only resolved this as what? 2.25. That means that your C9 is now in what? Parallel with what? C2. Is it making sense? Can I clear here? Alright, so we have gotten our C9. So the whole of this will now be in what? In parallel with what? C2. These C1, C8, and C3 are now in what? Parallel with what? With what? C2, right? This is the diagram here in parallel. Is it not? Okay. So what do we have here? C2, which is what? 2 microfarad. Here's what? 2.25 microfarad. So this is called what? C what? This is called what? Our C9, right? In parallel, what do we do in parallel? So that means the left is what? C what? Equivalent, Abi? Equals to what? C2 plus what? C9. So what's the C equivalent? C2 is what? 2 plus what? 2.25. So what's the C equivalent? 4.25 microfarad. Alright guys, thank you for following us. Ensure you like, you subscribe, and ensure you share to your friends. Thank you.